My first math is even 4. 25 enters both 25 and 225. I mean, that thing ends in 25, doesn't it? 25 has to enter. How many times does 25 enter 25x squared? Pull a 25 from that 25x squared, you get 25. You get x squared left. 9. Now that is a special pattern here. That's the difference of 2 squares. The factor's pretty easy. 25 sticks around. Takes an x and x to create the x squared, right? It takes a -3 and a +3 to make the 9.
So that doesn't matter what order you put the negative positive in.
Nope.
Unless you want the.
That's what I said, right?
What are you saying?
5x plus 15, 5x minus.
Yeah, you just would need if it was a factor completely, you would add 4 5 in both terms. That would have worked. Anyways, this is a solve problem. How do I solve for x now? Cover up method. 25 doesn't have an x attached to it, so it doesn't matter.
X equals 3,
If x minus 3 is nothing, x is 3. If x plus 3 is nothing, what's x? There's 2 x's. And you're going to see some funny things on your homework. I'll probably do it with this example. It says express 36 squared minus 21 squared is the difference of 2 squares. For some reason, the EOC test always puts funny things like this on there to confuse kids. It's on the no calculator part, and kids go offside and they do a crap load of math work, and they look at the answer choices. They have to do all the work on the math choices again. Is that a difference of 2 squares? Is there a subtraction symbol?
Yeah.
Are both pieces squared?
Yes.
Yes. And it just says express it, but don't ever figure out the value. So the difference 2 squares pattern, a squared 36 squared. What's that make a?
Negative 21 squared.
No. If a squared is the first piece and it's 36 squared, what's a? 36. B squared is the second piece and it's 21. What's that make b? 21. So you're actually just supposed to express that as a factored form. Right up here, a plus b, a minus b.
So 36
Plus 21?
plus 1, 36
Or
minus 21.
36 minus 21. Now see, it actually has some advantages if you want to do it by hand. You know, 36 squared is not something you all know, so you'd have to go off the side and do 36 times 36, wouldn't you?
Yeah.
And 21 squared is probably not something you want to do that. But now, if you want to do this by hand, you do 36 minus 21, which is 15. You add 36 and 21, and you'd say 15 times 57. It has its advantages. It's the way people used to do some math by hand, namely Pythagorean theorem. You can figure things out quicker using difference 2 squares pattern.
So if you do something like that, all you have to do is subtract it or add it.
This is actually the end result. That's the goal. Get to that. The factored form.
I'm saying, like, if you wanted to find like the actual angle, could you just subtract 21 from 36 and then add it and then multiply them 2 numbers?
Yep. That's it. Versus coming off the side and figure out 36 times 36 and 21 times 21 doing a subtraction. You end up working with a lot smaller numbers. It's kind of unique. Anyways, that's all the goal is here. And on your EOC, that's all the goal is. Just show it as a difference 2 squares. But you guys will do the same thing everybody does. You'll sit there and forget you ever shown that, and you'll do a whole bunch of math, and it'll take you 15 minutes to do a 1-minute problem. That's that. All right, this is a pattern that's on your formula quiz. You have not been held accountable for it up until now. This is the a cubed minus b cubed pattern. A cubed minus b cubed factors is a minus b. It's almost wrote plus. A minus b. Anybody here that should remember it? Spencer, you memorize it. What's the rest of it?
A minus b to a squared plus b plus ab plus b squared.
Right. Probably also in your notes somewhere too.
I almost had it. I had it mixed up.
It's a cubed minus b cubed. It starts with a minus b. That's how it starts. Now, there's also a sum of 2 cubes, and the lettering is the same, it's just the signs are different. We're only going to do the first modeled example here. Throw that little piece right there. Nope. We're gonna factor and solve for the real values of x. 125x cubed minus 8. It says factor. Do it by factoring. Now, one thing I did in another class, which probably makes sense for y'all, nobody really goes past 1 through 10 when it comes to cubes. Sometimes they do, for the most part they don't. What's 1 cubed?
1.
If you don't know these, you might make a list. I'll change the color over to red so you can see it. It's 2 cubed.
8.
8. How about a 3 cubed?
27.
27. How about a 3, sorry, 1 cubed. How about a 4 cubed? 64. 5 cubed? 125. 6 cubed? It's usually about when it gets quiet. 216. 7 cubed? I got quiet. 343. I'll just go ahead and finish it. 8 cubed is 512. 9 cubed is 729. And everybody should know what 10 cubed is. 1,000. You can handle this section if you know your cubes. That's how it works. If you know your cubes, this section's actually pretty easy. Now, with that being said, some of you guys aren't going to memorize because you don't know how to find the area of a rectangle yet at this point in your life because you've never memorized it. Do you know how you take a cube root on a calculator?
Yeah, you can get whatever number and then the top 3.
Not rooftop 3. Rooftop 3 takes the number and cubes it. On paper, we put a 3 in front of the square root. Calculator, we use exponential notation. The cube root of 343 is the third root. Notice how I'm saying it? The third root, as in the 1 divided by 3. To take a third root, you literally take a 1/3 power of something. That's how you do it on TI-84. 7 all day long. But you raise it to the 1/3 power. You're supposed to know 1 through 10. Really are. Anyways, we're going to factor and solve. And what you're going to do in the beginning is you think about how these pieces line up. 8 cubed is the 125x cubed piece. That's what 8 cubed is. It's that 125x cubed piece because of how it lines up. What do you cube to make that 125? Cube 5. What do you cube to make that x cubed? Just the x. I think you're somewhere else. And if you took 5x and you multiplied it by 5x and you multiplied it by 5x one more time, would you have 125x cubed? That's how you figure out the letter A, kids. How do you figure out the letter B? You take the cube root of 8. B cubed is 8. But you have your little table off the side now. What is the cubic root of 8? 2. Now, if you go home and you forget that, and you happen to have a TI-84, which you probably don't, you take 8 and you rooftop it with a 1/3 power. And it'll tell you 2 all day long. All right, so we know what A and B are. We plug into that thing right there. And it'll be factored for us.
5x minus 2.
5x minus 2, because he's plugging in, he's not doing anything special.
And 5x squared.
5x squared, you can write it like that?
Now I would do it as 5x cubed, 25.
Just saying, that's what you told me to write, right?
Well, you have to enter.
Yes, it has to be in some set of principles. It's 2 pieces that are squared, not 1. It's 2 pieces that are squared, not 1. The whole darn thing is squared. Plus, I heard 2. I heard to figure that. What else? A times B. 5x times 2. Plus what? Only a couple of y'all are answering like you're somewhere else. B is 2, kids. You're plugging in right there. Plus 2 squared. Now, I'm not going to show that for everybody. You guys need to see it set up a couple of times. That's like doing quadratic formula, just showing you the result. We had that question on quadratic formula in a minute, haven't we? We need to. All right. What is that 5x squared all squared? That shouldn't be there, right? 25x squared plus 10x plus 4. Now, we did have an equal. We were tasked with solving for all the real answers, weren't we? So we have 0 equals 5x minus 2 times 25x squared plus 10x plus 4. There's a nice easy set of parentheses right there leading this thing. If 5x minus 2 is 0, what's a real value of x? What is it? 2/5. And you also got this piece right here, 25x squared plus 10x plus 4. None of you guys know how it factors because you're all using photomath. You put that in photomath and it would actually tell you it does not factor. The second piece never factors. Not on this. A little note here. It never factors. Ever. Impossible for that piece to factor. So if you thought there were real answers there, what would you have to do? If you thought there were real answers there, what would you have to do? You have to do the quadratic formula. So if we did the little quadratic formula here, what would A be? A is 25. B is 10. The reason I'm going through this, go ahead and put your head down if you want. Anyways, quadratic formula goes x equals -3, -10 plus or minus square root b squared minus 4ac all over 2a. Now, inside that radical, you've got 10 squared, which is 100, minus 4 times 25 times 10.
Wouldn't that be 4 over there at the end? 25 times 4.
The 10 is a 4, thank you. I didn't have the numbers in front of me. All right, so 4 times 25 times 4, that's 400, isn't it? You have a -10 plus or minus the root of 100 minus 400, so over 50. Is that going to be real? Is that going to be real? This is not real. Why is it not real? Negative and radical. So not only does the second piece never factor, it's also never real. Second piece never factors and it is never, ever real. So pay attention to what's being asked of you. That thing asks for real answers. Do you care about the second piece? Nope. You need to do your homework. Don't care. If it says find real, don't touch it. What you got, Spencer?
So if it's telling you to solve, is there even a point to write out second piece?
If it says solve for real, yes, because I want to see it factored. The first instruction set was factor. There's another way to do that problem. Add 8, divide by 125, take cubic root. All right, so here comes the sum of two cubes pattern. The lettering is exactly the same. That doesn't change. So the signs are. You still got an A, you still got a B, you still got an A squared, you still got an AB, and you still got a B squared. The difference is the signs. Now this was A cubed plus, they're not all plus.
Oh.
Not the last one. The middle one's a minus. Lettering's all the same, just what plus and minus go. First one starts with a minus, the last two are plus. The second one is plus, minus, plus. Now there's an acronym on the next page, which I'm going to flip over to. It's called SOAP. It's how you tell the signs. It doesn't help you remember the lettering, but it helps you do the signs. The acronym is SOAP. And the S stands for same, because A cubed plus B cubed starts with A plus B. That's the same part. A cubed minus B cubed starts with A minus B. So that's same sign is what it means. O stands for opposite sign, because look at the second sign you see. Isn't it opposite of the initial sign? Okay. And the last one, it's actually the last, is always positive. We just kind of put our emphasis on the A and the P there so we can spell soap. Somebody in here asked last week what an acronym was. SOAP is an acronym. No, it was in this classroom, I think.
Yeah, it's good.
SOAP is an acronym. It's a mnemonic to help you memorize something. Did you ever figure out what SOCOTOA meant, Stephen? Oh, the acronym was SOCOTOA. You don't know what it means. I bet you're one of those kids that says, man, I was good in geometry. And you don't know SOCOTOA? You were not good in geometry. You had an easy teacher. You had an easy teacher. If you don't know what SOCOTOA is, you were not good at the course. You had an easy teacher.
Yeah, that's what it was. We had an easy teacher. Well, she was a good teacher.
If you don't remember what SOCOTOA was,
It's opposite over hypotenuse, adjacent over hypotenuse, and adjacent over opposite.
Opposite over adjacent.
Yeah, but that's where I missed on the form of the clues.
you'll have another one of those next week.
I'd be sounding stupid.
Well, don't feel bad. A lot of kids left it blank. Some kids don't know how to spell it. The only example we're going to do on here is this example B. It's a model example. Does that initially look like a sum of two cubes? No, why not? The powers are a fifth and a second. That doesn't jump out to you as the sum of two cubes. Now, I don't know what photomath would tell you to do on this thing, but don't trust it. You follow my 10 commandments. The first commandment is if you can pull it, you pull it. What can you pull from both pieces?
16.
You sure you can pull 16? Why don't you check it with a calculator? You might could pull a 4, but 4 is going to mess up your life.
What, 2?
Pull up 2. Pull out something else too. Squared. We're still on your pink phone back there, Garrett. Not during class. I love your mom, but not during my math class. Your mom will understand that. You can even tell her, as I said, don't be texting during my class. Now, if I pull a 2b squared from 16b to fifth, what remains? b cubed. This is why we pulled the 2 and not the 4. If we'd have pulled the 4, would we have been able to take the cube root of the 4 that was there? No, that's why we pulled the 2, so we could make an 8 there. You pull the 2 from 686. 343. Isn't that on your little list?
Yeah.
The goal was to create something that looked like a sum of two cubes. And we do have an equal, so apparently we're solving here too. But this piece stays out front. It doesn't go anywhere. And now we factor this guy. We're going to use that guy up there, that formula. But you got to tell me what A is. A is whatever you cube to become 8b cubed. To what? 3. We're out of time, aren't we? A is whatever you cube to become 343. 7. I need a bigger set of parentheses here, but the first piece is 2b plus 7. Now the second piece, what do we do with that 2b? Square it. What's 2b times 2b? 4b squared. What do we do with 7 and 2? We do that 7 and 2. Multiply. Minus 14b. What do we do with that 7?
Right.
You care about this last set for answers. No. You care about the first two sets, actually. If 2b squared is equal to 0, what's b? If 2b squared is 0, if you square to make a 0, we'll multiply by 2 and still be 0. 0. 2b plus 7 is 0. Negative 7/2. There's 2 of your answers. There's still 3 floating around. One of them actually happened here. That happened twice. 2 of them are here. Imaginary section. I guess I'll be able to do any more of your notes with you. Thanks. We did everything but, oh, we didn't have factor by grouping. We better do that. I got 2 minutes. Do the easy one. That one. I've done this technique with you before. Gently cover up the last 2 terms and think about what you can pull from the first 2. We'll have x squared. Leave you with x minus 3. Now, that piece has to match. They always match. X minus 3 is going to get repeated again. What do you pull from a negative 16x plus 48 to create x minus 3? Negative 16. You went from 4 terms to 2 terms because the multiplications happen between those pieces. What do both pieces have in common?
X minus 3.
X minus 3. And you're left with x squared minus 16. Hey, this thing's not even done.
That'd be x minus 3. And then x minus 4.
And
X plus 4.
x plus 4. Last one was the difference 2 squares. Instructions are there. Sorry I ran a little low on time.
So you just combine the 2 things, like that's not going to see.
Yeah, because what you're doing is you're doing this as 2 things. One thing, one thing. And you pull what they have in common. The rest of it is left over. That's factoring by grouping. You got your homework. I suggest you do it and not photo math. I'm not sure how Snapchat's doing it, but I downloaded Snapchat just to see how it does math.
Did you get it in?
I haven't had a chance to log in yet.
I've never tried them.
I'm sure it just integrates with photo math.
It just pulls up photo math.
Yeah, it just pulls up photo math. So don't be using Snapchat or photo math to do your homework. You need an app that teaches the way I teach.
You should make that. You know? Help her out, man.